Okay, number one, Cameron puts $400 into a savings account that earns 6% annually. All right, the amount in her account can be modeled by this given equation, where T is the time in years. Which expression best approximate the amount of money in her account using a weekly growth rate? Okay, so if we take a look at this original function here, right? T represents the time in years. So within the parentheses, that tells us the yearly growth rate. Okay, so this 0.06, if you move the decimal over twice, would be increasing by 6% per year. Now what they want us to do is they want us to find the weekly growth rate. Okay, so I just wrote out some important facts here. So there are 52 weeks in a year, right? So if we want to find the weekly growth rate, we're looking at the growth rate 52 times per year. So this number right here is what we're going to put in front of the t, in front of the exponent. Now, if we put a 52 in front of the t, that changes the value of the original function. So what we need to do to compensate for that is we need to put its reciprocal, 1 over 52, on the inside of the parentheses. Okay, so now from this point, we're just going to bring down the c of t equals 400. And you're just going to plug this into your calculator, 1.06 to the 1 over 52 power. Okay, so when you do, this is what you get. And then I'm just going to bring down the 52t. Okay, so now, since we have a 52t on the outside, this means 52 times a year. So this is the weekly growth rate that we see within the parentheses. So that matches up with choice 4. All right, so number 2 is similar to how we did number 1, but just the end gets a little different. So the Speedy Foot Shop has been selling a newly designed skateboard. The design has been very popular and the shop has seen an increase in profits over the past year. The number of skateboards sold in this design can be represented by this given function f of t, where t is the time in years. So again, if t is the time in years, then the number in the parentheses is the yearly growth rate, okay? So the 0.045, if you took that decimal and moved it over twice, it would be 4.5%. So it's growing by 4.5% per year. I know what they want us to do. It says in terms of quarterly growth rate. Okay, so quarterly, there's 4 quarters in a year, so that's going to happen 4 times per year. All right, so the number that I put here, the circled number, is what goes in front of the t. But by putting a 4 there, that totally changes the value of our original function. So in order to keep this equivalent to our original function, we compensate for putting that 4 there by putting its reciprocal, a 1/4, on the inside of the parentheses. All right, so now we're going to bring down the f of t. The equals the 4,200. And what you see in the parentheses here, the 1.045 to the 1/4 power, this is what you're going to plug in your calculator, okay? And when you do, you get I'm going to just stop rounding at what I see the answer choices do it at, 0, 1, 1. I'm going to close the parenthesis, and I'm just going to take this 4t and bring it right down. Okay, you know, I actually thought the ending of this was different than the first question. I don't know, I guess I wasn't looking ahead. I thought they were putting the answer choices this time in terms of Q, but they didn't. So this actually matches up with choice 1. If they did have the answer choices in terms of Q, so instead of having T's on the outside, 4t, 4 times per year, means the same thing as quarterly. So you could cross off this 4t and make it a Q instead. But they don't have that answer choice there. So anyway, choice 1 is the answer. Okay, number 3, which function represents exponential decay? I mean, honestly, the easiest way to do this is just to plug these in your calculator one by one, go to y equals, and see which one goes down by a rate instead of up by a rate. Okay, so here they are. I graphed them one by one, and you can see that choices 1, 2, and 3 go up by a rate over time, whereas choice 4 is the only one that goes down by a rate over time. So that's why choice 4 is exponential decay. So that's our answer. All right, number 4, they want us to find the inverse of this function. Okay, so if you guys remember, if you want to find the inverse, all you do is you just switch the x and y values, okay? So if we look at this original function, f of x is another way of saying y, right? So what I'm going to do is I'm going to switch this y, this f of x, I'm going to switch that y to an x, and then I'm going to switch this x to a y. All right, and then all you have to do is just solve for y, just get y by itself in the equation. Okay, so now there are a couple ways to do this. I'm going to stick with the way I did it on the answer key. So in order to get the y by itself, I first got rid of this number, and then afterwards I got rid of the number in front of the y. Okay, so the first thing I did, and this is not the only way to do it, was I added 3/2 to both sides of the equation. Okay, so that left me with x plus 3/2 equals, and then these cancel, and I'll bring down the 1/2 y. And then to get rid of a fraction in front of a variable, just multiply both sides of the equation by the reciprocal. So if I want to get rid of the 1/2 in front of the y, I'm going to multiply both sides of the equation by the reciprocal of 1/2, which is 2/1. Okay, or if you just want to write 2, I mean, it's the same thing. So basically, this 2 on top cancels with the 2 on bottom, same thing with the 1s, and it leaves us with just y. And here when I distribute, 2/1 times x is just 2/1x, or just 2x. And then 2/1 times 3/2. Well, if we multiply this fraction by this fraction, you can cancel off this 2 on top with the 2 on bottom, leaving you with 3/1, which is just 3. Okay, and then what you do in the end is you take this y and you switch it back to, we're going to write f inverse of x. I'm going to actually bring it to the left-hand side of the equation. So here's my symbol for f inverse of x. And then I'm just going to take the 2x plus 3 and bring it down. Okay, and we can see that that matches up with answer choice 1. And I just want to point out, I know in the beginning I said there was other ways that you could get y by itself. For those of you guys that saw these fractions and you were like, I don't want to have fractions, you could have from the beginning just multiplied both sides of the equation by the number in the denominator. So see how both denominators have a 2? If you just multiplied both sides of the equation by 2, you would have wound up with whole numbers rather than fractions on this side. And it might have made it easier for you. So it depends, however you want to go about doing it. Okay, so number 5 also wants us to find the inverse. So we know with inverse, again, we're going to switch the y to an x and the x to a y. Okay, so let's start off doing that. So I'm going to make this, instead of y equals, it's going to say x equals. And instead of 3x, we're going to have 3y. And then we have our plus 2. Okay, so all we're doing is switching the y's and the x's. And now we're just going to solve for y. So to solve for y, I'm going to subtract 2 from both sides of the equation. So it leaves me with x minus 2 equals 3y. Okay, so now I'm just going to divide both sides of the equation by 3. So these cancel off, and I can bring down the y. And then they just basically, if you look at the answer choices, instead of leaving it as x minus 2/3, they individually did 1x/3, brought down the minus sign, and then did 2/3. Okay, so again, because there's really a 1 in front of this x, you could write this as 1x/3, which is the same thing as 1/3 x. And then I'll take this subtraction sign and bring it down. And then we have 2/3. Because if we look at the answer choice, we have y equals, so it's got to be choice 2, 3, or 4. And this is 1/3 x minus 2/3. Okay, just like choice 3 says. So this is, choice 3 is our answer. Okay, number 6 wants us to find the solution to this equation. Now, I mean, if you look ahead at the answer choices, you could tell, just by the way they're written with the radical and the plus and minus, that we're going to wind up having to use the quadratic formula. All right, so let's get started. First thing you want to do is you want to get one side of the equation set equal to 0. So I'm going to subtract 3 from both sides of the equation. Okay, so basically these are going to cancel off. Let me rewrite it up top so I have more room. So I'm left with 18x squared minus 24x. Okay, I'm literally just bringing this over bringing this over, but then these numbers are going to combine. 90 minus 3 is positive 87. And then on the right-hand side of the equation, 3 minus 3 cancels, leaving me with 0. Now, if you look at these numbers, I mean, you could plug them right into the quadratic formula, but you should be able to recognize that these first two numbers are both divisible by 6, but also by 3. And think about this. If 90, we know, is divisible by 3, and you take away 3 from it, shouldn't 87 also be divisible by 3? So basically, all of these numbers right here are divisible by 3. So to make my life easier, you don't have to do this. You could jump right into the quadratic formula. But if you want to deal with smaller numbers to make your life easier, you can divide both sides of the equation by 3. All right, so now that's going to leave us with 6x squared minus 8x, and then plus, without your calculator, I mean, if 90 divided by 3 is 30, wouldn't 87 divided by 3, 87 is 3 less than 90, just be 1 less than 30, right? It would be 29. And then 0 divided by 3 is just 0. So this is the equation that I'm going to use to plug, into the quadratic formula. So if you look at this, we know that A is 6, B is negative 8, and C is 29. All right, so x equals, let's plug it right into the formula. X equals negative B, so negative 8 would be positive 8, plus and minus the square root of b squared. So if you take this b and square it, negative 8 squared, negative 8 times negative 8 is 64. Or you could write out negative 8 in parentheses squared, minus 4 times a, which is 6, times c, which is 29. And we're going to put this whole thing over 2 times a. So 2 times 6. All right, don't forget to write x equals, right? If this is an equation, see how there's an equal sign here and an equal sign here? You have to keep it in equation the whole way through. So don't forget about the x equals. On, a test, you lose a point for that one. So x equals 8 plus and minus. Now you're just going to figure out what 64 minus 4 times 6 times 29 is. So that gives you negative 632. It's a larger negative number under there. Divided by 2 times 6, which is 12. Now, just a reminder, please don't try to simplify the 8 and the 12, right? Even though they're both divisible by 4, because you have to also be able to simplify the number that comes after the plus and minus, and there's technically a 1 in front of the radical. So what we first do is we simplify the radical. All right, I'm going to do that over here off to the side. So I'm going to simplify the radical negative 632. All right, now, because of this negative, right, normally what you do is you would break up positive 632 into 2 separate radicals, and then because we have a negative, we need a third radical for the negative 1. All right, now, 632, you may be like, that's a really big number. Like, what's the biggest perfect square that divides evenly into it? So you could sit there and start dividing it until you find it out, but look at the answer choices. They all have a radical 158. So I would just take 632 and divide it by 158, and when you do, you get 4. So that means we're going to break this up into 4 times 158. Okay, so if it's multiple choice, try to take advantage of, shortcuts with your answer choices. Okay, so now the square root of 4 is 2. I'm going to jump over here. The square root of negative 1 is I. And then I'm going to just bring down the radical 158. Okay, so in our equation over here, let's replace the radical negative 632 with 2i radical 158. Okay, so we'll have x equals 8 plus and minus 2i radical 158 over 12. Okay, so now that we simplified our radical, now we have numbers, an 8, a 2, and a 12. Now we have 3 numbers. You need all 3 of them to be able to simplify. So the biggest number that divides evenly into all of these is 2. So the 8 is going to become a 4, right? 8 divided by 2 is 4. The 2i is going to become a 1i because 2 divided by 2 is 1. I'm just going to write I. And you could bring down the radical 158. Okay, that doesn't simplify because this is under a radical. And then 12 divided by 2 is 6. All right, so that leaves us with, well, you know what? If you look at the answer choices, they break it up into A plus, really plus and minus, BI form. So we're going to do the same thing here, okay? So I'm going to break this up into 4 over 6 plus and minus. I'm going to write it right now as just as I see it. I radical 158 over 6. Okay, and then if you look further, right, you want to see, do any of these individual fractions simplify? This one does. 4 over 6 simplifies to 2/3. So this is 2/3 plus and minus I radical 158 over 6. All right, so let's see what answer choice that is. So 2/3. So it has to be choice 3 or 4. Now, technically there's a 1 in front of this I, right? So isn't this really like 1/6 I radical 158? Okay, so that is what we see in choice 4. So choice 4 is our answer. All right, so now the next one, number 7, same directions, except it's not multiple choice. They want us to, basically solve this equation, find the roots. And they're telling us to write our answer in simplest a plus bi form. Okay, so I first rewrote the equation to give myself a little bit more room. And also, if you notice, since these were fractions, I took the -2 and put it over 1 to make that a fraction too. Okay, because when you're solving a fractional equation, the first thing you want to do is you want to find a common denominator. All right, so if you look, this denominator says x minus 3, so the common denominator has to include an x minus 3. And this denominator has an x. Now, there's nothing you can multiply this by an x to make it say x minus 3. So we're also going to have to include the x in our common denominator. So far we need an x minus 3 times an x, and then this one has a 1. A 1 is the only thing, technically you don't really have to include it because isn't there really a 1 in front of this x already? So really in our common denominator we need to include x minus 3 times 1x times x. So let's start with the first fraction. This has the x minus 3, but it's missing the x. So let's put it there, okay? If we want to I'll just put it over here. If we want to put it there, we can, as long as you also put it in the numerator. Okay, so whatever you put in the denominator, you have to put in the numerator. So now this denominator is x times x minus 3. Technically this should be in parentheses since there's 2 terms. Okay, now let's look at our next number. This has the x, right, which we see there, but it's missing the x minus 3. So let's put the x minus 3 there. Okay, and if I put it in the denominator, I also have to put it in the numerator. Okay, and if we look at our last fraction, it just has the 1. It's actually missing the x and the x minus 3. So let's put it there. Let's put the x there as well as the x minus 3. And same thing, if you put it in the denominator, you have to also put it up here in the numerator. Okay, and now that all the denominators say the same exact thing, we can take those denominators and we can just cross them right off. Okay, so what we're solving is this equation we see above. And I really prefer for you guys to first rewrite it, because if you don't, I find a lot of people forget to distribute this negative, not just to the first term, but to the second term. So I'm going to rewrite this. All right, so we have x times 5x minus 4 times x minus 3 equals negative 2x. Okay, I'm just going to put these together as one term, times x minus 3. Okay, so x times 5x is 5x squared. And now we're going to distribute this negative 4 to both terms in the parentheses. So negative 4 times x is negative 4x. And then negative 4 times negative 3 is positive 12. Okay, negative times negative is a positive. And then negative 2x times x is negative 2x squared. And negative 2x times negative 3 is positive 6x. And since we have exponents greater than 1, right, x squared, if you had x cubed, x to the fourth, any exponent greater than 1, you want to get everything to one side of the equation. So since this is a positive 5x squared and this is a negative 2x squared, I don't want to have negatives in front of my leading coefficient, right, in front of my term with the biggest exponent. So I'm going to take these two terms and move them to the left-hand side of the equation. Okay, so we could do that by adding 2x squared to both sides of the equation and line it up under its like term, under the other x squared term. And then I'm also going to subtract the 6x from both sides of the equation. So that leaves me with 7x squared, right? You just add the numbers and you keep the variable term, you keep the exponent. Don't try to add those exponents and make it x to the 4th. Okay, and then here when we combine these, it gives us negative 10x. And the 12, we don't have anything to combine that with, so you're just going to take it and bring it right down. So plus 12 equals 0, right? All of this cancels. That's why we moved it over. All right, so now we know whenever you see this a plus bi form, it's cluing you into, I'm probably going to have to use the quadratic formula. All right, so let's do that. All right, so we know with the quadratic formula, here I'll label these. A is 7, B is negative 10, and C is positive 12. All right, so x equals negative B. So negative 10 would be positive 10 plus or minus the square root of B squared. So negative 10 squared. Negative 10 times negative 10 is positive 100. And then minus 4 times A, which is 7, times C, which is 12. And that whole thing is over 2 times A. So 2 times 7. And again, I want to remind you, you have to have the x equals. Okay, if this is an equation, there's an equal sign all the way through. Don't forget the x equals, because then you're taking it out of equation form and making it into an expression. All right, so x equals 10 plus and minus. And then you just have to figure out what 100 minus 4 times 7 times 12 is. So that gives you negative 236. And that whole thing, right, even the 10, make sure you start the fraction bar from the beginning to the end, is going to be over 2 times 7, which is 14. All right, so I'm going to take this and simplify it off to the side just so it's not all cluttered in the problem. So radical negative 236. Now, because we have a negative, we know we're going to need like an extra radical with a negative 1 in it. And then you're just going to break up the 236. So, I mean, you could take 236 and start dividing it by 2. You don't get a perfect square. By 3, you don't get a perfect square. By 4. When you divide by 4, it gives you 59. And since 59 cannot be broken up further, 4 is the biggest perfect square that divides evenly into it. Okay, so the square root of 4 is 2. The square root of negative 1 is I, and then you could bring down the radical 59. Okay, so radical negative 236 is equal to 2i radical 59. So I'm going to replace this with this within our equation. All right, so I'm left with x equals 10 plus and minus 2i radical 59 over 14. Okay, now that we simplified our radical, now we can simplify these numbers. Okay, don't try to do it in this step up here, because technically there's a 1 in front of the radical, and a 1 isn't going to simplify. But if we look at this, we have a 10, a 2, and a 14. They're all divisible by 2. Okay, I'm going to work my way this way now. So if I divide each of these by 2, 10 divided by 2 is 5, and then plus and minus. 2 divided by 2 is just 1. So you could write 1i radical 59, or just I radical 59. And that's going to be over 14 divided by 2 is 7. Okay, now if you look back up at the directions, it says A plus BI form. So what that lets us know is we have to break this up into an A, which is 5 over 7. And then plus, which technically is plus and minus. And then a BI, which would be I radical 59 over 7. If you prefer to write this as radical 59 over 7 with the I on the outside, that way it's like a B times I, you can do that. All right, so let's just look. You have to look at your individual fractions now. Can this simplify? Nope. Can this simplify? Nope. So here, this is our answer. This is what x is equal to. Okay, so in number 8, it wants us to determine the zeros. So basically, whenever you want to determine the zeros, you're just going to set this equal to 0 and solve for x. Okay, so in order to start this, I mean, you could do one or two things. You can either, if you look at all of these terms, you could either pull out the greatest common factor, which would be 2 and then x squared, Or if you want to get rid of the 2 altogether, you could divide both sides of the equation by 2. But you can't divide by 2x squared. You can't divide by a variable, because what happens when you do that is you eliminate some answers, because then you're changing the value of your highest exponent. So I think what I'm going to do is I'm just going to factor out the greatest common factor. I'm just going to factor out the 2x squared. Okay, and that's going to leave me with x to the 4th plus x squared minus 72. And then I'm going to bring down the equals 0. Now, if you're confused with how I got that, this is all I did. I had 2x to the 6th, and I took out a 2x squared. So the 2 came out. I had 6 x's being multiplied together, and I took 2 of them out, so it left me with 4 of them. Okay, then I brought down the plus sign. I had the 2, I took it out. I had 4 x's being multiplied together. I took 2 of them out, so it left me with 2 of them here. Then I brought down the minus sign. Now, out of 144, I took out a 2. When you take some out, you're dividing. Okay, you're doing 144 divided by 2 is 72. And I had x squared, but I took them all out, so I didn't have any x's left for here. All right, so let's keep factoring. So I'm going to bring down the 2x squared. And then since there's a 1 in front of my first term, I'm just going to set up 2 sets of parentheses. And since this is an x to the 4th, I'm going to put an x squared in the first spot in each parenthesis, because x squared times x squared gives you x to the 4th. And then I'm just going to come up with 2 numbers that add to positive 1 and multiply to negative 72. Okay, so that's going to be positive 9 and negative 8. And let's bring down the equals 0, because if it starts off as an equation, you have to keep it an equation the entire time. Okay, now nothing can be factored further, so this is where I'm going to jump into making my t-chart. Now, once you make your t-chart, what you can do is you can individually take each factor. So here's the first one, 2x squared, and you're going to set it equal to 0. Okay, same thing here. Let's take this factor, the x squared plus 9, and set that equal to 0. And then the final factor, we're going to set equal to 0, and you're just going to solve these one by one. Okay, so let's start on the left. In order to solve this, I'm first going to divide both sides of the equation by 2, which leaves me with x squared equals 0 divided by 2 is 0. And then to get rid of a square, we take the square root. So it leaves me with x equals. Now, normally when you take the square root, right, we write plus and minus, because this tells us there could be 2 answers. But the square root of 0 is 0, and there's no such thing as positive 0 or negative 0, so I'm just going to write x equals 0. Okay, so on this left side of the t-chart, we wound up with just one solution, because there's no such thing as plus and minus 0. All right, now over here, I'm going to subtract 9 from both sides of the equation. So it leaves me with x squared equals negative 9, and then I'll take the square root. So it leaves me with x equals. Now this time, we're going to need a plus and a minus, okay, because we're not dealing with 0. Now, the square root of 9 is 3, and the square root of negative 1 is I. So the square root of negative 9 would be 3i. Okay, so in the middle part of our t-chart, we wind up with 2 answers, positive 3i and negative 3i. Okay, and then finally over here, we're going to add 8 to both sides of the equation. So we have x squared equals 8. And then we're going to take the square root. So it leaves us with x equals plus and minus. Now, radical 8, the square root of 8 is not a perfect square. So I'm going to have to break this up into 2 separate radicals. And the biggest perfect square that divides evenly into 8 is 4. So I'll make this a 4, which leaves me with a 2 in the other radical. And since the square root of 4 is 2, it leaves me with x equals plus and minus 2 radical 2. Okay, so altogether, from the beginning, since this was a 6-degree equation, we could have had 6 answers. But we only had 1, 2, 3, 4, 5, because there's no such thing as plus and minus 0. So that eliminated one of our answers. All right, number 9. Which value to the nearest tenth is not a solution of when p of x equals q of x if, and they tell us what p of x is equal to, and then they tell us what q of x is equal to. Okay, so all they're looking to do, whenever they want to know when one function equals another, really you can graph these and find out where they intersect. Okay, so what I'm going to do is I'm going to plug this into y1 in my calculator, and then I'm going to plug this into y2 in my calculator. And then if we want to know when does p of x equal q of x, if you take what p of x is equal to and set that equal to what q of x is equal to, you'll notice there's only x's in that equation. So we're looking for the x values of where they intersect. Okay, I'm going to do this on my calculator and show you exactly how to do it. Okay, so I went to y equals in my calculator and I plugged in these two equations. And what I'm going to do is I'm going to go to, let me say, second, trace, and then I'm going to choose choice 5, which is intersect. Okay, so I'm going to hit the number 5 because I want to go to where it says intersect. Now you'll see that there's y1, and then there's y2. So what you'll notice is that we have, let's see, 1, 2, and then if this graph continued, right, there'd be another point of intersection up here, 3 points of intersection. All right, so what I'm going to do is I'm going to use my arrow keys. I'm going to start with this left arrow key, and I'm going to move my cursor until I get as close as possible to this first point of intersection. Now, if you notice, I can't get right on it, but as long as you're closer to that point of intersection than any of the others, you're going to hit enter 3 times. So you're going to hit enter, 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 until you see right here where it says intersection on your screen. Okay, so remember, we only care about the x values. So to the nearest 10th, this is negative 3.9. Okay, what you could see right here is choice 1. So choice 1 is not the answer. We're looking for which is not a solution. Okay, so choice 1 is out. Okay, now we're going to have to repeat this process. We're going to again go to second, trace, intersect. So second, trace, and then choice 5. So I usually just hit the number 5. It's faster than scrolling down and hitting enter, right? Now this time we're going to move our cursor. So I'm going to use my right arrow key, and I'm going to move my cursor over to the next point of intersection, which is right about here. Okay, and then I'm going to hit enter 3 times. So enter, enter, enter. And you'll see that this, sorry, it's shaky to hold this iPad while I'm trying to do this. This point of intersection is at negative 1.1, which is choice 2. So that's not the answer because we want to know which is not the solution. All right, so now let's do it a third time. So I'm going to go back to second, trace, choice 5, intersect. Now, I know that this is off I'm going to use my right arrow key, okay? I know I'm going to be going off the screen a little bit, but that's okay. As long as I move this, you know, closer to that point of intersection over there than it is to the others, I'm going to again hit enter 3 times. So enter, enter, enter. And you can see that this is at x equals 2 point, that would round to 1, 2.1, which is choice 3. So it's not choice 3 either. I can't see what choice 4 says. Let me see if I can move this down a little. There we go. So choice 4, which is 4.7, is going to be our answer. That's not a solution to when p of x equals q of x. Okay, so number 10 is really similar to number 9, where we want to know when does g of x equal h of x. So we're going to take what g of x equals and plug that into y1 in our calculator. We're going to take what h of x equals and plug that into y2 in our calculator. And then we're finding the x values only, so the x values of the point, of their points of intersection. Okay, so I'm going to do it the same way I did the last one. I'm just going to guide you through it on the calculator. All right, so the first thing I'm going to do is I'm going to plug g of x in. So I'm first going to hit the number 3. And then it says the absolute value of x plus 1. Now, if you forget how to get an absolute value, you just go to, this is how I do it. You go to math, over to NUM, and that first one there says ABS. That stands for absolute value. Okay, so we're going to plug in x plus 1, and then we're going to go out of the absolute value bars. So I'm going to use my right arrow to get out of them before I hit minus 2. Okay, then I'm going to go down to y2, and I'm going to plug h of x into y2. All right, so that says x cubed plus 2x squared minus 3x minus 4. Okay, So now, if we wanted to determine their solutions, we're looking for where they intersect. So we're going to go to second, trace, and then choice 5, intersect. All right, so let's see. There's y1. There is y2. So we'll see that they have 1, 2, 3 points of intersection. So, I mean, to show work, since this is not multiple choice, you could just sketch a little graph of this. It doesn't have to be great, just a little sketch on your paper. Okay, I have the camera going here, so I don't really have room to do that, but you see on my answer key, I do have the graph there. And let's find the 3 points of intersection. Okay, so we're gonna go to, well, I already did second, trace, intersect. So I'm going to take my left cursor. I'm gonna start, I always start on the left. It doesn't really matter, but I'm gonna first find that point of intersection. So I'm gonna hit enter, enter, enter. And remember, we only care about the x values of the point of intersection. So to the nearest 10th, right, this, they want you to round to, this would be x equals negative 2.2. For some reason on my answer key, I have negative 2.1. So that's a mistake. I'm going to have to change that. All right, so I will do that. Hopefully by the time you watch this video, it will be corrected on my answer key, but we'll see. Okay, so that's x equals negative 2.2. Okay, now I'm going to go back again to second, trace, and choice 5, intersect. And this time I'm going to use my right arrow key to move it over by the next point of intersection, which is like right about there. Okay, it doesn't have to be right on it, but once you get somewhere closer to it, you're going to hit enter, enter, enter. So, and we'll see this one is at negative 0.7. So x equals, I'm going to write negative 0.7. Look at that, on my answer key, I have positive 0.7. Woo, my answer key is really messed up here. So hopefully I will be changing that before I post this video. So it's at negative 0.7. Okay, and then finally, I'm gonna again hit second, trace, intersect for the third time. And I'm gonna move my right arrow key till I get to the third point, and again, just hit enter, 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 and you'll see that the x value is at positive 2.1. Oh, finally, I have one right on the answer key. So that's at x equals positive 2.1. Okay, so again, hopefully before you watch this video, those will be corrected on the answer key, the physical answer key. So hopefully you won't even see those mistakes. Okay, so number 11. So they give us a picture of h of x, and they want to know what is the remainder when h of x is divided by x plus 1. Okay, well, the remainder when h of x is divided by x plus 1 is the value of the function at x equals negative 1, okay? So if you're dividing by x plus 1, we want to think about what is the value of the function when x equals negative 1. Okay, so what we're doing is we're really finding h of negative 1. Okay, so when x equals negative 1, what is the value of our function? Okay, so I'm going to go over to negative 1, and the y value of the function here is at a height of 0. So 0 would be the answer. 0 would be the remainder. Okay, so the next one, what is the remainder when h of x is divided by x minus 1? So if we're dividing by x minus 1, we want to know what's the value of the function when x equals positive 1. So we're finding h of positive 1. Okay, so when x equals positive 1, what is the y value of the function? Well, it's all the way up here at positive 8. So all you're really doing is you're looking for the y value when x equals the opposite sign of what's given to you. Okay? All right, so what is the remainder when h of x is divided by x? Now, x, this has no number attached to it, but isn't x the same thing as x plus 0 or x minus 0? So really, I mean, the opposite is 0. The opposite sign of 0 is still 0. So we're looking at when x equals 0. Okay, so we're looking for h of 0. So when x equals 0, what's the y value of the function? So here's where x equals 0. the y value of the function right there is at positive 6. All right, number 12, it wants to know which of the following is false. Okay, so let's go through these one at a time. I'm actually going to start with number 4 and work my way backwards. You'll see why when I do it. Okay, so starting with choice 4. If you have x being raised to a power, and there's another power on the outside of that, whenever you have a power raised to another power, what you do is you multiply those powers. Okay, so I'm going to make this 2 over 1. So if I want to take 2/3 and multiply it by 2 over 1, that would give me 4/3. So I could rewrite this as x to the 4/3. Now, if you recall, power over root. Okay, the power is the number on top, and the root is the number on bottom. That's supposed to be a 3. It came out a little sloppy. So since that's a 3, that would be the cube root of x to the 4th power, okay? Power over root. So the cube root of x to the 4th power, which is exactly what this says. So this one's true, so that's not our answer. All right, let's take a look at the one above it. So again, we have a power being raised to another power. So we multiply the exponent, so that would give us 3/4. So we could rewrite this as x to the 3/4 power. So again, whenever we have a fractional exponent, we can say power over root, meaning the numerator is the power and the denominator is the root. So this can be thought of as the 4th root of x to the 3rd power. The 4th root of x to the 3rd power, which is what this says. So choice 3 is also true, so that's not our answer. All right, the next one, I'm working backwards, number 2. Again, we have a power being raised to another power. Now, since this is a fraction, let's make the 3 into a fraction by putting it over 1. So now if you multiply the fractions, 3 times 1 is 3, and 1 times 4 is 4. So you get 3/4. So I could rewrite this as x to the 3/4. And again, we have a fractional exponent, so whenever that happens, you could write it in radical form, right? So this is power over root. So the 4th root of x to the 3rd power. The 4th root of x to the 3rd power. So this one is also true. So choice 1 has to be the answer, but let me just go over why. So if we do the same thing, if we take this power and raise it to the other power, we're going to multiply our exponents. So let me put this 2 over 1. So we multiply, we would get 3 times 2, which is 6, and 2 times 1, which is 2. 6 divided by 2. 6 divided by 2 is just 3. This simplifies to x to the 3rd power. Now, when you have just a whole number right here, you're not going to write it in radical form. Because technically, isn't 3 the same thing as 3 over 1? There's no such thing as the 1th root of x to the 3rd power, okay? And anyway, even if there was, which there's not, this is the 4th root of x to the 3rd power. So the left-hand side of the equation is not equal to the right-hand side of the equation, so choice 1 is our answer. All right, let's take a look at number 13, which looks like it also deals with exponents. Okay, use the properties of rational exponents to determine the value of y for the equation. All right, I'm going to say anything after the comma over here, right, anything over here, you can pretty much ignore. This right here, from here to here, is our equation. Okay, so we want to use this equation to solve for y. All right, so we know that if we have, something written in radical form, how for the last question we were saying power over root, okay, we can rewrite this as x to some fractional power. So since 8 is the power and 3 is the root, we can rewrite this as x to the power over root, x to the 8/3 power. Okay, so I'm going to do it over here so I have more room. X to the 8/3 power. Again, because it's power over root, and that's the power and that's the root. Okay, now times. All right, so even though you don't see a number in here, this is really the square root of x to the 3rd power. So if it helps you to put a little 2 in there, because that's what the square root means, there you go. So we can rewrite this using power over root, x to the 3/2 power. Okay, here's my power, just like that's the power, and here's my root, just like that's the root, okay? And then on the bottom, if you have a power being raised to another power, just like in the last question, we're going to put that over 1, and you multiply your exponents. So we're going to have x to the 4/3 power. Okay, and then I'm just going to bring down the right-hand side of the equation, x to the y. All right, so now you just have to know your exponent rules. So let's start with the numerator. So if you're multiplying two terms with the same base, right, they both have a base of x, you just add these exponents. You can either do it by hand, find a common denominator and add them up, or if you want to do it in your calculator, you could type in 8/3 plus 3/2, math, and then hit math, enter, enter. Either way, it's up to you, whether you do it by hand or in the calculator. 8/3 plus 3/2 is 25/6. So we get x to the 25/6. And I'm just going to leave that over x to the 4/3 for right now. And I'll bring down the x to the y power. Okay, now, if you're dividing two terms with the same base, you subtract these exponents. So if you want to do it by hand, you can find a common denominator and subtract them. If you want to do it in your calculator, you can just use your calculator to subtract them. Either way, 25/6 minus 4/3 is 17/6. So I'm going to rewrite this. You keep the base and you subtract the exponent. So I get x to the 17/6 equals x to the y. Now what they wanted us to do is they wanted us to determine the value of y. Well, since y is an exponent on the base of x, and since this fraction is the exponent on the base of x, it must mean that y equals this exponent. So in this problem, y is equal to 17/6. Okay, so number 14, Gia's grandparents gave her $4,000 for her 18th birthday. Gia, having learned about how important it is to start saving early, is deciding on two investment options. Okay, so let me do this. I'm going to make a line going down the paper like this because I want to do option 1 on the left side and option 2 on the right side. Okay, so option 1 is going to go here and option 2 will go here. Okay, so starting with option 1. Option 1 will pay her 4.75% interest compounded continuously. Okay, we know whenever we see compounding continuously, we're going to use our Apert formula. Okay, so I'll fill in the numbers in a minute. Now it says that option 2 will pay her 4.38% compounded quarterly. So when you see compounded anything other than continuously, we are going to use our compound interest formula. All right, I'm just going to finish reading the problem and then we will plug in the numbers. Ooh. Okay. Algebraically determine to the nearest year, let me just underline that because that's important, what to round to, how much faster it will take for the better option to triple her money. Okay, so if we want to triple her money, let's think about this. She's investing $4,000. So if she's going to triple that, we want to know, 4,000 times 3 is 12,000. How long will it take to grow to $12,000? Okay, so let me start with option 1. So I'm going to plug in $12,000 for the A, for the amount that remains after a certain time has passed. For P, the initial amount, we're going to plug in her initial amount of $4,000. All right, now in option 1, the rate was 4.75%. So if we take this decimal and move it back once, twice, it'll become 0.0475. Or if you prefer, you could always just take this number and divide it by 100, and your calculator will move the decimal for you. Okay, and we're going to leave that in terms of t because that's what we're solving for. All right, I'll solve that in a minute. And let me just go to option 2. So option 2, the ending amount is still going to be 12,000. We want to know how long is it going to take to triple. So how long will it take to grow to 12,000? The initial amount is still 4,000. That's what she had to invest. And the rate here is now different. This is 4.38%. So if I may move the decimal place back twice, or if I take this number and divide by 100 in my calculator, it'll give me 0.0438. Okay, and I'm going to divide that by n, which is the number of compounds per year. So if something is compounded quarterly, it's compounded 4 times per year. So I'm going to replace this n with a 4, as well as this n, and I'm going to leave it in terms of t and solve. Okay, I'm going to come back over here to option 1 and solve this one. So the first thing we're going to do is we're going to divide by 4,000 because we're trying to get that base of E by itself. So 12,000 divided by 4,000 is 3. and I'm going to bring down the e to the 0.0475 t power. All right, now to get rid of an e, we put an ln in front of it. And if we do that to the right-hand side of the equation, we also have to do that to the left. All right, so I'm going to bring down the left-hand side of the equation, ln of 3. Now, over here, what happens is when you have ln of e to any power, that's just equal to whatever the power was. So this side of the equation is going to be equal to 0.0475 t. All right, and then to get the t by itself, we're going to have to divide both sides of the equation by the number that's in front of the t. So we're dividing both sides of the equation by 0.0475. Okay, this is a 7, by the way. All right, so that leaves me with t equals. So you're going to plug this in your calculator, and I'm just going to for right now, round to 4 decimal places on my paper. So this gives me approximately 23.1287 years. Okay, so that's how long it takes for option 1 to triple her money. All right, now let's go over to option 2. So we start this one off the same exact way. We're first going to divide both sides of the equation by 4,000. So that leaves me with 3 equals, and in parentheses I have 1 plus, sorry, it's not coming out right, 0.0438 divided by 4 to the 4t power. Okay, now here, instead of using natural log, we're going to use just regular old log, okay? And the reason I'm going to put log in front of both sides of the equation is because the log allows me to take this exponent. It's called the power rule. It allows me to take my power and bring it to the front of the word log. All right, so let me get back on the lines here. So we have log of 3 equals, now the 4t comes to the front, so 4t times log of what's in the parentheses. All right, so now to get the t by itself, we're going to have to divide by log of what's in the parentheses as well as by 4. All right, so I like to divide by log of what's in the parentheses first, but to be honest, it totally doesn't matter. Okay, so I'm dividing both sides by log of 1 plus 0.0438 divided by 4. So that on the right-hand side of the equation, these cancel, so I could bring down the 4t. And then on the left-hand side of the equation, you're going to have to just plug this in your calculator. And, you know, as much as we try to avoid rounding on our paper, we are going to have to round. So we get approximately 100.8782. But be sure to leave that number in your calculator, because at this point we have to divide by 4, and you don't want to divide the rounded answer by 4. You want to divide that entire answer in your calculator by 4. So in your calculator, you're literally just going to hit divided by 4. All right, and when we do, we get 25. This is, rounded again, 0.2195. All right, so let's just take a look here. Now, let me move this up a little so I have a little more room. It definitely takes faster, right, for option 1 to triple her money than it does for option 2. But they want to know how much faster, and then they want us to round to the nearest year. Okay, so if you look back up here, we want to know how much faster and round to the nearest year. All right, so if we want to figure out how much faster, let's just subtract these two numbers. Okay, so I'm going to take the longer time, right, the bigger number, and I'm going to subtract the shorter time, the smaller number, from it. I mean, and in your calculator, you really should scroll back up and do this entire number minus this entire number. All right, when we do, we get approximately 2.09. So they want it to the nearest year, so this rounds to 2 years. So we can say this right here, option 1 will triple her money 2 years faster. Okay, and finally we're on to number 15, which is the last question. So this is another investment one. Nick has $8,000 he would like to invest in an account. He is considering 3 investment options. Okay, so let's take a look at these one at a time. Option A will pay him 2.4% interest compounded annually. Now, I just want to remind you, whenever we see the compound, compounded annually, compounded quarterly, monthly, anything, we're going to be using our compound interest formula, which is this one right here. Okay, this is our compound interest formula. So this one says compounded annually. Annually just means once a year. But even still, we're going to be using this formula. Now, because they want us to write, in part A, a function, we don't want to just write A equals. We normally would write A of t equals, but because they're telling us to use n to represent the years, right? Instead of A of t, we're going to write A of n. Okay, n is representing the years here. Okay, so then he's investing $8,000, so we're going to plug that in for the P. And then it's 1 plus. Now the rate, they tell us, is 2.4%. So if I take that decimal and move it back twice, it becomes 0.024. And we're going to divide that by n, which is the number of compounds per year. Now, annually means once a year. So I'm going to take this and divide it by 1. Okay? And if this n is a 1, this n is a 1 as well. And then they want us, instead of using t for years, they want us to use n for years. So this right here is our equation. Now, whenever something is compounded annually, you really don't need this one here or this one here. Because think about it, isn't 0.024 divided by 1 just 0.024? So if you prefer to just rewrite that, I'm going to erase this, as just 0.024, go for it. It's probably going to make your life easier later on in other parts of the question. And if you prefer, instead of rewriting this as 1n, to just rewrite that as n, go for it, because you don't need that, you don't need that 1 there. All right, so here we go. So whenever something's compounded annually, honestly, what you're using is your regular exponential growth formula. Okay, A equals P times 1 plus the rate to the usually t power, but in this case, n power. Okay, so now option B. Option B will pay him 2.375% compounded quarterly. So again, we're compounded something other than continuously, so we're going to use our compound interest formula. This time I'm going to write B of n just because it's option B. So B of n equals, now the P is still 8,000, right? That's how much money he has to invest. And then it's going to be 1 plus, this time our rate is 2.375%. So if I take the decimal and move it back twice, or if I take my calculator and divide this by 100, I'll wind up with 0.02375. And I'm going to divide that by n, the number of compounds per year. So if something is compounded quarterly, there's 4 quarters in a year, it's going to be compounded 4 times a year. So we're going to replace this n with a 4, as well as this n with a 4. And then again, instead of bringing the t down like we normally do, they want us to use n to represent years, right here. So we're going to put an n right there. Okay, and then finally, option C. Now, option C will pay him this percent compounded continuously. So now we see the word continuously. When you see that, that tells us we're going to use our APERT formula. Okay? So now, again, we have to write it in function form. Instead of, I've already used A of n, B of n, so let's use C of n equals, and he's investing $8,000. Going to bring down the E. Okay, this time our rate, if I move this decimal back twice, will be 0.0235, and that's also going to be to the n power. Okay, so these are our 3 functions that Nick, I guess, is going to have to decide between. Okay, so the next part, part B. Which account will earn the most money for Nick over the next 10 years? All right, so basically, since n represents time, if we want to figure out which will earn the most money for him over the next 10 years, we're going to replace each of these n's, right, the time, with 10. Now, when you write this, not only do you want to replace these n's with the 10, but you also have to replace these n's with the 10. Please don't write A of n and then replace this n with the 10. if you're replacing this n with a 10, you have to do that as well. So this should say a of 10, b of 10, and c of 10. Okay, so let me just move this up a little. So I replaced all of the n's with 10s, right? And I did the same thing here. And then all you're going to do is plug this in your calculator, and because it's money, you can round to the nearest cent, okay, which is 2 decimal places. Same thing here. You can plug this in your calculator, and because it's money, you can round to the nearest 2 decimal places, okay? And same thing here. We're going to just plug this in the calculator, and this is what we get. So you want to look, and you can see, well, account A is going to earn the most, then account B, and then account C. They just wanted to know which one would earn the most, so you just want to write out your answer. Option A will earn Nick the most money over the next 10 years. All right, so in letter C, it says algebraically determine to the nearest year how long it will take for option B to double Nick's initial investment. So what I did was I just put the function to represent option B right here. And if we want option B to double Nick's initial investment, here's his initial investment. It's $8,000. So if you double 8,000, that'll give you 16,000. So we want to know how long will it take for it to grow to $16,000. So the left-hand side of the equation represents the amount that's in the account after a certain time has passed. So we're going to replace that with 16,000. And then from here, we're just going to solve. All right, so let's first divide both sides of the equation by 8,000. So that leaves us with 2 equals what's in this parenthesis being raised to the 4n power. And then because we're solving for an exponent, we can put the word log in front of both sides of the equation. And the reason we do that is because the power rule tells us you could take a power, you could take an exponent and bring it in front of the word log. All right, so we're left with log of 2 equals 4n times log of what's in that parenthesis. Okay, so to get this n by itself, we have to get rid of the 4 as well as the log of what's in that parenthesis. So we're going to have to divide by both of those. All right, I'm going to first divide by log of what's in our parenthesis there. And that way on the right-hand side of the equation, those cancel out, and I could bring down the 4n. Now this you're going to have to plug in your calculator, and on your paper, we're going to have to round. But remember, you're going to leave that entire number in your calculator. So on your paper, you can round to 4 decimal places, and this is what we get. But in your calculator, you're going to leave that in there and just hit divided by 4. So it's going to take the answer and divide it by 4. And when you do, you get approximately 29.2717. Now they want it to the nearest year, so this would round to 29 years. All right, and then finally, letter D. So letter D, I could see right here, is going to be using option C. Okay, and it wants to know how long will it take for option C to increase Nick's initial investment by $4,000. So if his initial investment is $8,000 and we want to increase it by $4,000, well, 8,000 plus 4,000 is 12,000. So we are going to replace this side of the equation with 12,000. All right, and this is what we're going to solve. So let's first divide both sides of the equation by the number that's in front of the e. All right, so 12,000 divided by 8,000, or 12 divided by 8, is just 1.5. And then what we're going to do is we're going to cancel off the 8,000s, and we're going to bring down the e to the 0.0235 n power. All right, so now that we have the e by itself, we're going to put ln in front of it to get rid of it. And if we do that on the right-hand side of the equation, we have to do that on the left-hand side of the equation. All right, so we're left with ln of 1.5. And remember, ln of e to any power is just equal to whatever that power is. So it's equal to 0.0235 5n. Okay, and then just divide by the number that's in front of the n. And that's how we'll get the n all by itself. Okay, so we're going to plug in our calculator, ln of 1.5 divided by this decimal, and when we do, we get approximately 17.2538. And let's see, they want it this time to the nearest tenth of a year, so that'll round up, right? That 5 rounds it up to 17.3 years. And that's it.